Hey there, crew. Day one, basic probability. Let's get this party started. Tree diagrams. So tree diagram is a way to list all these possible outcomes in a sample space. So if we look at this Banana Boat ice cream store example, we're going to pick 4 different flavors of ice cream and 2 different possible toppings. Now, tree diagram will help us organize all of the possible sundaes that can be made with these choices. So starting with our first set of options, we have mint, chocolate, strawberry, vanilla ice cream. If we get mint ice cream, we branch off and could get fudge as a topping, or we could get gummy bears as a topping. So that's why it's called a tree diagram, because we're kind of forming a tree with these branches. Let's go down to chocolate. We could get chocolate ice cream with a fudge topping or gummy bear topping. You see how it works? And this is a tree diagram. This allows us to see all of the possible outcomes and create what we call a sample space. So the sample space is we can have mint with fudge, and we do this notation, mint with fudge. We could have mint with gummy bears. So I'm listing what we call the sample space now. We can have chocolate with fudge, chocolate with gummy bears. We could have strawberry fudge. You get the idea, I'm sure. Strawberry. Okay, so I just listed the sample space. I'm trying to hold a phone and it's making me write really messy, so I apologize. So how many possible outcomes are there? We can count 1, 2, 3, 4, 5, 6, 7, 8. We have 8 possible sundaes we can make with these 4 ice cream choices and these 2 topping choices. This comes down to the fundamental counting principle, which I think is on the next page. So we have 4 choices for ice cream. We have 2 choices for a topping. That gives us a total of 8 possible outcomes. Outcomes, sample space, tree diagram. Are the outcomes in the sample space equally likely? Well, yeah, right? All of them occur once. Mint, vanilla, or fudge, excuse me, doesn't occur more times than the other options. So, yeah. Let's go to the next page. Okay. Oh, there it is, the counting principle. So that's what I just kind of explained. It will give you the total possible outcomes. So if one choice can occur M ways, like we had 4 options for ice cream, and the second choice can occur N ways, like we had 2 choices for our toppings, then the total number will be of outcomes or possible sundaes will be M times N. It's called the fundamental counting principle. So we can use that if they're asking us just to figure out the total number of outcomes. For example, if Ellen has 4 pairs of pants and 3 shirts and 3 scarves, how many outfits, including a pant, a shirt, and a scarf, can she put together? So we would just multiply 4 times 3 times 3 and find that there are 36 outcomes or outfits. See that? Okay. So instead of having to draw out the tree diagram with the 4 different pants and then branching off and 3 different shirts and branching off and et cetera, the fundamental counting principle comes in really handy. So next question, a delicatessen serves sandwiches on rye bread, white bread, or rolls. There are 8 different sandwich fillings, and customers have a choice of lettuce or no lettuce on the sandwich. How many different sandwiches can be assembled? So we start with how many options for our bread? 3 options, times 8 different options for fillings. I can't even think of 8 different fillings, can you? And then lettuce or no lettuce, so 2 choices there. So again, we're going to do 3 times 8 times 2 and get 48 different sandwiches can be made. Okay. I'll let you look at these next few. See what you think. There are 4 entrances to a building. 3 escalators go up. 2 escalators go down. How many ways can a person enter from outside, go to the 2nd floor, return to the 1st floor, and then leave? So, start here. How many ways can the person enter? 4. How many ways can they get to the 2nd floor? 3. How many ways can they get down? 2. And how many ways can they leave the building? 4. Okay, so we're going to multiply 4 times 3 times 2 times 4. My time is over 5 minutes, so I'm going to stop here. I'll post the rest of the fundamental counting principle key.